What's up, guys, and welcome back to the shop. Today we have a fun one. We had this, I think it's a 96 Subaru wagon come into the shop. It's right-hand drive, and it needs a part that you can't source. So in today's video, I'm gonna show you how we make that part from scratch. So over here on the bench is the part. This part you can't get anymore. It's an intake charge tube, I think they call it. It's got many names. This one is from Japan. They do make them here in America and you can get them, but the Japanese ones are really hard to come by. Now they do make a aftermarket version of this, and the owner tried to acquire that one and use it. The problem is both inlets for the turbos are oversized by about 2 or 3 millimeter, and it's just a sloppy fit. And also you can't really tell from looking at it, but this is a pretty bulky setup compared to the stock one, and it just, like most universal parts, it doesn't fit really well. It's not very accurate. You might be able to make it work, but it really is not ideal. It hits the power steering, it doesn't fit the turbos. So today's job is going to be to manufacture a new pipe out of aluminum that has the same dimensions roughly as the factory unit, but fits and is a lot more durable and is going to work well. So here are the materials we're going to be making this from. I got all this stuff from McMaster-Carr. It's 6061. I ended up going with 1/8 inch wall, which I know is thicker than what you're going to traditionally use to do like intake piping, that kind of stuff. I did that so that it would be a little bit easier to weld, but mostly so it'd be a little bit more durable, because we're not really concerned about weight here, and it's going to be a little bit of an unusual shape. So that's the aluminum. We do have some billets over here that I got. We're going to be turning these down so that I can do some flanges for both ends, and then some bar stock so we can go ahead and make the ears for mounting, and then some round. We have to turn down some nipples and that kind of stuff. We also have a vibrant clamp here. It has 6 degrees of movement per side, and it's a quick disconnect. We're going to be using that to mimic over here this flex joint, because there's no way to manufacture this on a solid pipe. It's really just there for installation. There's no movement from both sides of the turbo, but it is there so you can get it in place. So that vibrant clamp will kind of offer as intermediate piece so that it's not completely rigid. We can put it together in 2 pieces in the car and keep it nice and sealed tightly. And there is a little bit of movement in the clamp, so it's there if we need it. And then for couplers, we have a variety of couplers. There's a lot of challenges with this build, and we're gonna review those in a minute. But here are some couplers we're starting with. Most of these are standard sizes, so I believe 2 inch, 1 3/4. This is 3/4, and then these are metric, but we have some problems with that. All right, take a look at the engine bay. This is what we're gonna be working with. We have 2 turbos here. We've got one on the left and then one on the right. The main issue with this build, among many issues, is that everything is in metric. So these turbo housings, these ones are blocked off, but you can see the actual outer diameter of these turbo housings are 46 millimeter, both of them, and that is a abnormal size. Most couplers you can get are standard, and a standard one fits on nice and loose like that. I did not want to do that, and I spoke to the customer. There's no lip on this turbo, and everyone I talked to on the phone, multiple shops, that's all they could source me, was a standard closest fit, which would be 1 7/8, I believe, and it's just not going to work. I know in Japan or in Europe, if you guys are watching, you guys have tons of metric stuff, but based on the time frame, we just could not get our hands on anything metric. I was able to source one American company that did have a 46 millimeter to 57 millimeter adapter, and you can see it's a nice snug fit, which is exactly what I wanted. The only issue is the first thing is, if you look at this is a reducer, and I really would have liked a standard coupler. I don't think we're gonna have enough meat here on the 46 millimeter side to use this. The other issue is a couple of these came ripped, and they're obviously Chinese, so the quality is not very good. And the reality is I don't want to build this whole system around these really odd couplers that I had a hard time sourcing, and their quality is questionable at best. So we're gonna come in here and we're gonna turn up a sleeve that slides on here and is slit, so that way we can use a coupler that is a normal size and a higher quality. And then in the future, if there's an issue, it's not gonna be a nightmare to get the right coupler. So we already discussed some of the issues of the 46 millimeter piping. We have a couple more issues. First off, this design has the rubber molded into the plastic and it's very tight. Obviously I cannot manufacture something like that. It's the same thing here. These pipes are rubber and they're molded in. I can go ahead and do a standoff here, but in order to do that, I'm gonna lose a little bit of space and the tolerance is really tight. Also, we have a dongle here or a nipple that we're gonna make. That should be no problem. And then we have these ears that will machine and then TIG weld on. But basically the main issue here is these plastic or rubber molded pieces. They're molded in, and in order to maintain a similar clearance, it's gonna be really difficult to basically do an adapter, because when I'm manufacturing this, what I have to do is I have to make an aluminum standoff so that way my rubber piece can slide on, and it's gonna be real thin. It can't be too thin because it needs to be able to allow for a hose clamp and also have a lip preferably so that the hose clamp doesn't slide off. So in order to do that, we're probably gonna have to recess the nipple here and make all of these silicone connections male nipples that rubber can slide over. And of course, both of these are metric, they're 20 millimeter. Now, luckily, the 3/4 pipe that I was able to get is a lot closer to 19 millimeter than over here, 1 7/8 being close to 46. So I tested that and that will work. So we're just gonna go with that. But other than that, between 1, 2, 3, 4 rubber hoses that are pre-molded and a 5th pre-molded hose that we're gonna solve with a Van Jan clamp or whatever the vibrant clamp is, the heavy duty clamp. Those are the main issues with this. Now, I also know that this is a job that many shops aren't gonna take on. I'm one of like 10 shops that he's taken it to, and everyone has turned it down. No one has even considered making this part. But I love cars and I love trying to do the jobs that other people can't do. And this is a job for fabrication and machinist, and I'm ready to take it on and get it done. I know it's gonna be challenging, but stick along for the ride and see how we make it work. There are some clearance issues that we're gonna need to deal with. As you can see, the piping is thinner here. There are certain things in the car that we do need to have clearance for, like on the backside, you know, there's a jog and some stuff like that. So we'll be fabricating that. And then there's other areas where, hey, maybe this pipe could be round and it's not gonna actually contact anything. So we can get away with a round pipe. We're just gonna have to see how it goes as we go ahead and fabricate this thing. All right, a little bit of a long-winded intro there, but hopefully that gives you an idea of what we're working with, and it'll sort of make sense as we go along. The first step of this whole job is going to be to make some adapters over here on the lathe for the silicone couplers. We're gonna be using these 1 7/8 couplers, and I'm gonna make some split bushing, so we'll go and do that now. All right, we found a piece of 2-inch stock. It's gonna work perfectly. I tested it with the hose, it's a nice fit. It just has a factory finish. We're gonna go ahead and put a hole through the center and then take it over to the blue lathe so we can go ahead and finish boring it out. We have a 1 5/8 drill bit. We're just gonna do it in one shot. Being aluminum, no pilot, should be fine. There we go. See if this chuck can hold this thing. Not gonna be much of the material left, so. Take a measurement on this guy. I know it's super hot, I'm aware of that. All right, guys, we went ahead and got these spacers turned. They're a nice tight fit. They're not gonna go on there unless they're hammered on. I actually decided not to slit these things because I realized if I put a slit in them, even though that will allow this to spring and be really nice for clamping, it's going to provide a nice little slot for air to get through, and we don't want that. We want a nice seal. So instead, what I'm going to do is, these are aluminum, so I'm going to heat them up, get them to expand a couple thousandths, 3, 4, 5 thousandths, slip them on. Once they cool off, they'll be a nice fit, and they'll be nice and tight. They'll make the diameter larger, and I think that will work fine. Because of the way this is designed, this doesn't really have any, the intake doesn't have ability to move back. So I don't think there's gonna be an issue of it popping off per se. And as this expands, so will this. They're both aluminum, so I think they'll expand at the same rate. I don't think we're gonna have any leaks there. So that's what we're gonna do. All right, here's our first failure. This happens, just sharing it. Try to put this on. It's gonna be a perfect fit, I can tell, but I had it on crooked and couldn't get it on quick enough. It started to shrink and I had to destroy it to get it off. So we're gonna try the other one. We're gonna have to make another one of these. Yes, that took 20, 30, 40 minutes, an hour to make. We'll make another one and try to get this guy on here. Bring it back when it's done. All right, here's our junk one. We got the new one machined up. It fits nice. We got the other one on there. That one's been cooling down, nice and tight. Doesn't turn or anything. Very happy with how that turned out. All right, check out the fit now. Nice and tight. There it is right there. A lot better. Pulling on it, that's what we want. All right, so now that that's the starting point, we got both of those done. There it goes, in focus. We're gonna start actually making the manifold, but we needed to get that done first. All right, over at the lathe here, we got a piece chucked up. We're gonna make a piece like this. It'd be way easier to buy something like this, but we need to make it a little bit custom. I'm just gonna make a longer length of this with a lot thicker wall thickness and a little bit different lip design. But other than that, we'll jam it out, and then once we're done, we're gonna cut it in half and use 1/2 for each side of the turbo inlet to go ahead and start our intertake runner pipe. Got another big drill bit chucked up. We're running at a quick RPM. We're running at 615. And again, I'm not gonna pile it, I'm just gonna roll. Quick and dirty. All right, we got our hole drilled out through the middle and just cleaned up, 1.625. We're gonna come in and shape this on the lathe so that way we can get the part we need. All right, we got one side done. Slips on nice. Make sure we got enough room for the clamp. All right, so this is all the room I need, so I can part it off right there, give me enough room for a weld, trying to keep it as low profile as possible. The other piece will be a little bit longer because I gotta make a 45 and I want as much meat as I can, so that'll be perfect. Making the second bushing. And working with this aluminum is so nice. Just take some heavy cuts. Lathe doesn't care. Inserts don't care. All right, should be within 20 thousandths of final size here. And take it down to 0. Match the other one. All right, so we went ahead and got our parts made. So this longer piece is gonna be for this side over here because I'm gonna need some extra material. I think I gotta make like an angled cut here as the pipe comes along, so I left some extra material here. The wall thickness is overkill, but the minimum diameter does match this. It's a little bigger actually, and that meat will just help me when I'm welding it so it doesn't burn through, and it'll be a little more durable. So that's done. This side over here, same thing, nice and short. Over on this side, it's real tight. I have this little fuel line here that we're gonna have to tweak out of the way just barely, and then it's gonna make a sharp 90, just enough to slip the hose on there and put the hose clamp on. But other than that, pretty much all the minimum room required. So the next step is I'm gonna take a break, go grab some food, come back. We're gonna lay the manifold on here, see what kind of clearance we actually have in the real world here around this area. And then we're gonna start bringing our piping around here. And then somewhere in here, we'll have the actual hose clamp disconnect thing. All right, this next part's gonna be fun. This is probably one of the more difficult parts. So I put the manifold on, and this is exactly the right shape it needs to be to clear everything, of course, right? So I need to make my aluminum pipe have a real short lip here. So this lip that I cut is even too big. There's not enough room for it. And then I need to take this pipe and do a pie cut and a real sharp radius here and bring it all the way around. And then right in that region, there needs to be a male nipple welded there, so that way we can get that hose on. So I'm gonna bring you back once we get that pie cut taken care of and we work our pipe around that way. All right guys, we made a little bit of a change of plan. I started to do pie cuts so I can go ahead and make this transition here. But what I remembered is I can actually buy a vibrant pre-molded tight radius bend, and that's gonna save me a lot of work and be a lot smoother of a airflow, which is important since we're right by the turbo. So instead of making that part, I'm gonna use a pre-made part, and it'll work out well. Next step, I'm gonna make a jig over on the bench so that way we can get this mocked up, and that way I can have a place to test fit the part I'm making. All right guys, so here's the jig I came up with. Nothing crazy. Try to do this one-handed here. So we pull this away, and that's kind of an outline, and all these pieces are kind of floating at the right height. All right. I decided to do an outline as opposed to doing like rods, because I need to be able to get this in and out. So as much as I wanted to do like a post over here for clearance, the reality is I got to pull this back. So at least the outline will let me see down so that I know that I can clear it, but also give me the ability to remove it. All right, so I think this will be really nice. What I'm gonna do is I'm gonna make sure that my mock-up fits this jig and it's within the outline. And then once it does that at a minimum, I'll go over to the car and test fit it, and then make any modifications from there. But I think this will be a good starting point. It'll save some time, but also give a better result as well. All right guys, this is the first weld over here. Happy with how it turned out. We had to end up welding this little flange onto this 90. I know there was already a lip on there to begin with, but I actually cut this back shorter because it's a really, really tight bend. And then I didn't have a lip on there, and I really wanted a lip on there. So we got that welded. I'm actually gonna file this down so that way we can make this transition as flat as possible. And then under here, we have some room for the hose to get. It's really tight, so we're just really working this in. Over here at the hide mech, making some pie cuts at the saw. Okay, we got this set up. We're gonna do some more pipe pieces here. We got it curving this way, and we're gonna bring it back. All right, so we're doing like a small S curve. So we're gonna line them up kind of like that. All right, and then keep bringing it around. All right, guys, I'm real happy with where we turned out. So I went ahead and did a bunch of pie cuts here, and then went ahead and welded that out and ground it down so it could match the cast look here. And then if we take a look, I actually shortened this and then filed a ridge in there so that my silicone pipe has a nice register, and I have a hose clamp that's extra thin that will fit on there, and it'll keep it from hopefully popping off. And then we welded on, kind of hard to see. All right, there we go. So we welded on this Vibrant quick connect clamp. Comes apart. It's looking really good when I put it up here next to the diagram. We're looking really close. All right, and obviously next to the old one, you can kind of see it's pretty close. Let's see how it looks on the car. Over at the car, you see I had to make a little bit of clearance here on the block, and this is just a mock-up. So there we go. Everything floats. That clamp spins around without touching. It's really close, but it does fit, and then obviously our coupler will go there. I'm very happy with how it's turning out. It's a real tight fit, but I think it's turning out good. All right, we're coming along real good. We got this piece here. We got some pie cuts along with a straight section. I just kind of got it laid on there. It's actually not lined up, but it's really close. I'm real happy with that. So we're gonna get these pie cuts welded up. On this project, we're gonna be welding this and then blending the welds back down. So put a heavy bevel on each one of those pipe. That way there's plenty of material there. Other than that, let's get this welded up. All right, guys, we're coming along pretty good, but I just want to take a minute and explain this if it isn't obvious. Why we're doing this. Most people are thinking, well, you can just make a bend or buy a bend right here and weld it in, and that's true. That's what I did over here, and then we modified it. But the issue is the bends are so sharp, they don't make bends that sharp, and a lot of them are compound. So we make these little pie pieces, and we stack them and tack them, you know, and we get the exact radius, or very close to the exact radius we want. It's extremely labor intensive making these small pieces, beveling them, welding them. But yeah, it allows us to get these bends, which are really strange, you know, like this real tight S. So yeah, that's why we're doing this, and it's allowing us to be able to get a pipe that is basically unmakeable with pre-made bends and get it done. All right, guys, we got this pipe welded up over here around the pie cut radius. Just want to take a minute and talk about this. I'm really happy with the way this turned out, but if you take a look, like, these aren't Instagram welds, right? It's not a Kane kid over here laying dimes. And the reason is because I just don't have the seat time or the mass time putting in the hours doing this kind of stuff. And that's completely normal in a job shop like mine, where I really don't do a lot of TIG, and I especially don't do a lot of pie cuts. Most of what we do is heavier duty stuff, and so I just need to practice more. But considering that this is one of the first times I've done these pie cuts on aluminum on a small pipe, I'm really happy with the way that turned out. And in this project, we're grinding these down anyway, because we need as much clearance as we can because it's a really tight fit. So just wanted to show you guys this so you could see, you know what, this is the real world. It's going to work perfectly fine, but perfection is just not always possible. So I'm happy with it, and that's where we're at. Now that we got this welded up, we're over here at one of my favorite tools, the 2x72 belt grinder that I built. We got a fresh built on here, and we're gonna go ahead and get this ground down. I absolutely love this tool. Now we're gonna do some hand shaping with the slack belt of this band 5. There we go, guys. Looking good. That's what it looks like when I finish sand it. Our piece is turning out really good. We're doing some tube notching on the lathe here. Got the extended arbor and the hole saw for the 2-inch. Got a special setup here where we got our demo pipe clamped. We're gonna make a test cut here, make sure it works. We'll go test fit it, and if it's good, we'll use the final pipe here. All right, we're gonna max out here, so we need to relieve this area back here. Here we go, there's our test cut. A little rough, but it'll work. Check it out. Nice fit up right there. There it is right there. Pretty good. All right, so and this is gonna go into a larger pipe, so that's gonna be fine anyway, and we'll get it fine-tuned. All right, here's where we're at. We got this done, lines up good. There's our little V-joint there. Everything lines up good. The next step is to make this hose that goes from here to here. If you look on the factory one, it's pretty wide. I calculated the area, and it's about what a 2.5-inch pipe would be squished into an oval. I have a 2 1/4 pipe, and then I have a 3 1/2. The problem is I really don't want to go with this smaller pipe and limit the airflow, because after this point we have airflow from both turbos in one short hose, and I really don't want to restrict it. So what I'm gonna do is I'm gonna take that pipe and I'm gonna squish it into an oval, and then I'm actually gonna extend it so that way we have a little bit more volume in that area. I really don't want it to run into any issues with too much air trying to get in there. Over at the bandsaw, getting this pipe split. Was milling those pieces strictly necessary? No, but I wanted to get a nice good fit, and we got that. I'm trying this ducting tape. It's supposed to be high temp. We'll see if it holds up for the tacks, but I just got the tape holding it in place. I'll manipulate it with my hand as we tack it, but you can kind of see we're going for an extended oval here just to increase the surface area inside there. Well guys, I'm gonna go out on a limb and say that was worth it. Getting that thing milled up turned out really nice. We got it tacked and we're getting ready to get this thing welded out. Getting it milled allowed us to get a real nice tight joint. Getting it tacked is a little bit of a pain, but I'm really happy with how it turned out. It's nice and straight. The inside of that pipe will add some extra volume and be nice and flat. All right guys, we got our part cleaned, wire brush set up, clamped down, and we're gonna try to lay down some beads on this thing. Definitely do better in a straight line than I do on a round, that's for sure. Using an aluminum flap wheel will get this ground down. All right, I've been working at this for quite a while, but I think it's gonna be pretty worth it. So check how close that pipe fit is. This hose is in the way. You can actually see light, you can see it right there. Maybe a 16th, real tight fit. I actually filed the header or the manifold just a little bit, just so they're not rubbing. There's a look down there. You can't even see from that angle. Very proud of that. And then over here, similar deal. You can see light in there. Yeah, there you go. You see the light? So we're talking 16th. But you see how tight this is. Holy cow, man. That's not as tight over there. That's tight. So we're still working. You know, obviously you can't even see, but I gotta get that hose in there up to this point here. And it's got a snake. So, so far it fits. It's real tight, but you know what? It fits, and that's about how the stuff works. It's a thin margin for error. It's an exact fit. All right, we got all that blended out, turned out nice. Got my pie pieces here. We're gonna put together a little pie section here that curves around so we can make that curve right there. We're over here at the lathe and we have our 3-inch elbow chucked up here. This elbow is a tight radius cast like we used on the other side. We're gonna use this for the inlet for the air box. The only issue is the thickness here over the flange is maybe a millimeter too big, maybe a little less, like 100 thousandths or so. So what we're gonna do is we're gonna come in here and we're actually gonna skim this down using the parting blade, and then this lip is a little too big. So it'll be real tight, but we're gonna come up here right next to the chuck and trim that back a little bit. And we just give it a spin to make sure nothing hits. And we're good. All right, let's get this flange. We're real close to the chuck here. I got a stop set, so I think we're good, but we'll see. There she is. All right, guys, I'm super happy. This is the old one, and this is the new one. We got everything done. Turned out really good. What we do need to do is I need to add these tabs on. That's gonna be the next step, and get this fitted up. This is very close, maybe 95% there. We might need to do some clearancing. I've been doing some clearancing for the last hour, and it looks like it fits, but I'm not gonna know until I bolt it up via these holes. So let's get these tabs manufactured and welded on and kind of go from there. In order to keep the same position for the mounts, here's what we got. We just got some studs welded in with holes through here. So that way when we take the stock one out, these pieces of metal will be in the exact location for where the mounting holes are, and we can weld in our tabs based on those locations. All right, guys, it's 12 o'clock at night, and we finally got this taken care of. This is such a tight fit. 16th there, 32nd there. Over at the turbos, we're good. We're good. It's real tight. It's not touching, but it's real tight. And the nice thing is this is actually bolted to the manifold. So it's not gonna move around, it's not gonna rub through or anything like that. It's got a bolt here and then 2 bolts under there. I've spent at least 4 or 5 hours just taking this on and off, making sure that it's gonna fit properly and adjusting it, adding material, etc. So I think we've got it dialed in. The only thing left that we have to do is just do our little nipples here. There's gonna be 6 nipples in total for airline. I think it's for vacuum type stuff. So that's all we got to do. I'm really happy with how it turned out. Very challenging job because it is so tight. A lot of really working with the material, but I'm really happy with how it turned out. We went over to the lathe and we got this turned up. We're gonna get it mounted right there, so that way we can attach a hose just like the stock one. Cranked out this bung over here on the lathe. Gonna get it punched in and welded on in that spot. All right, guys, we got this finished up. Did a lot of work off camera, especially on these nipples and ends. I had a guest come into the shop and just didn't have time to film, and really just needed to knock this project out. I've been working on it a little bit longer than I expected, and I kind of expected that would be the case. So overall, this turned out really good. I'm still waiting on some small crimp style hose clamps for these. They'll be here in a couple days, and I ordered new O-rings here. When I did a water test, I found out that this flange was crushed. It was a little bit out of round, so I machined a new one, and then one of the O-rings was torn, so I ordered some new O-rings. I ordered some from MasterCar and from Vibrant. Apparently they're proprietary. I'm not really sure if I believe that, but I got the OEM ones as well as the ones that matched using my O-ring measuring gauge. So overall, this isn't perfect. It's really, really close to about as good as I could do given the scenario, and I think it's really good, to be frank. This is a very tight fit over on the car. We're talking 16th to 32nd inch clearances. Every slight bend and jog is where it needs to be within a pretty decent tolerance. and making this was very detail oriented. And the reality is it'll work. It will fit, the hoses will line up, and it will work. And that was the point. We wanted to make something that would work because the old part could not be sourced, and it will work. And yeah, that is the goal. I may or may not paint it. It really doesn't matter. The only part you can see is like this part here when it's on the car. But yeah, I hope you enjoyed the build. And if you have any questions, post them down below, and we will see you in the next video.